Lab 1 covers constant velocity and how observed motion differs from theoretical motion. The purpose of this lab is to examine Newton's second law in action. I observed and recorded the motion of an object and compared the observed motion with a computational model based on physics principles. Based on the momentum principle, a change in momentum means there's a net force acting on the system. These equations, based on the momentum principle, show how the net force on the object must be zero for the object to have a constant velocity. First, I recorded the motion of an object and used Tracker to collect data of the object's change in position over time. Next, I created a computational model based on physics principles. I inputted the object's mass, initial position vector, and velocity vector. I found the velocity vector using the initial change in position over time based on the tracker data I collected. I also changed the time interval and the ball's velocity equation to reflect the momentum principle using the velocity update formula due to the fact that the net force must be zero in order to obtain a constant velocity. Here's the position time graph of the observed motion and the model's motion. The nonlinear slope of the observed motion indicates a non-constant velocity. It is also important to note that the slope of the model's position over time is based on the fact that I used the initial velocity from the tracker data I collected. However, if I use different tracker data from a different time interval, the slope of the model's position over time graph would be different. What if I switched the direction in which x was positive? Because my object moved to the left, I indicated that that was in the negative x direction, thus the slope of my position versus time graph is negative and the data is below the x-axis. However, if I had indicated that movement to the left was in the positive x direction, then the slope would be positive and the data would be above the x-axis. What does this all mean? The velocity observed was not actually constant. Why not? Well, we know from the momentum principle that for velocity to be constant, the net force must be zero. Let's look at the vertical components of the net force. We have weight and normal force. These forces are equal due to the fact that there was no change in the y direction of the object's observed motion. However, we know the horizontal components were not equal because the object did change its velocity over time. So either the friction force or the applied force was greater than the other. Additional components of error include the fact that the distance at which I recorded the object's motion may have affected how distance was perceived in the tracker program.